Class 12th Chemistry, Unit 13, Amines, and in this video we will discuss about basic character of amines. Amines, being basic in nature, react with acids to form salts. This is the reaction RNH2. When react with this HX, this will form RNH3X, that is a salt. The same way, this is aniline. When react with HCl, this will form C6H5NH3Cl, anilinium chloride. Amine salts on treatment with a base like NaOH regenerate the parent amine. Like this is the salt which is formed in this first reaction RNH3X. When react with the base like OH minus, it will again regenerate this amine. Okay. Amine salts are soluble in water but insoluble in organic solvents like ether. This reaction is the basis for the separation of amines from the non-basic organic compounds insoluble in water. Amines have an unshared pair of electrons on nitrogen atom, due to which they behave as Lewis base. Okay, that is presence of lone pair of electron on the nitrogen. It can be donated, that's why they behave as a Lewis base. Basic character of amines can be better understood in terms of their Kb and pKb values. Now let us see. This RNH2, when react with the H2O, this NH2 will accept a proton from this water and convert into RNH3 plus, and this is OH minus. Now if we write the expression for Kb, what is this Kb? Kb is the base dissociation constant. Then this can be written like this: concentration of product in the numerator, and in the denominator concentration of reactant. And this H2O is a solvent in the pure liquid state, that's why its concentration is taken as a unity. Now this is Kb. Now if we take the negative log of this Kb, we will get the pKb. Now if higher the value of Kb, stronger the base. Okay, then if Kb is higher, then pKb will be lower. That's why we can say larger the value of Kb or smaller the value of pKb, stronger is the base. pKb value of ammonia is 4.75. Aliphatic amines are stronger bases than ammonia. Why? Due to plus I effect of alkyl groups leading to high electron density on the nitrogen atom. Their pKb values lie in the range of 3 to 4.22. Aromatic amines are weaker bases than ammonia due to electron withdrawing nature of the aryl group. Now you can see this table. Amines are given and their pKb values are given. Now you can say this is first these. Okay, these are the aliphatic amines. Okay, now this benzylamine, this is a aromatic amine. This is phenylmethenamine. This contains again aromatic ring. That's why its pKb value is greater than these aliphatic amine but lower than this aromatic amine. Okay, so we can say aliphatic amines are stronger bases than ammonia and aromatic amines are weaker bases than ammonia. Now structure-basicity relationship of amines. Basicity of amines is related to their structure. Basic structure of an amine depends upon the ease of formation of the cation by accepting a proton from the acid. The more stable the cation is relative to the amine, more basic is the amine. Okay, whatever the cation formed by accepting the proton, then if that cation is more stable, then its basic nature of amine will be more. Now we will compare the alkyl amines versus ammonia. Due to plus I effect of alkyl group, that is alkyl group, pushes electrons towards nitrogen and thus makes the unshared electron pair more available for sharing with the proton of the acid. The substituted ammonium ion formed from the amine gets stabilized due to dispersal of the positive charge by the plus I effect of the alkyl group. Hence, alkyl amines are stronger bases than ammonia. You can see this is the ammonia. It accepts the proton and convert into ammonium ion. And this is primary amine. It accepts the proton and this will form substituted ammonium ion. Okay. Now in this case, this nitrogen bears the positive charge and this alkyl group being have electron releasing effect, that is plus I effect. It releases the electron to this nitrogen and disperse this positive charge. More the dispersion, more the stability of this cation and more the basic nature of that amine. Okay. That's why the basic nature of aliphatic amine should increase with increase in the number of alkyl groups. Okay, that's why we can arrange the different amines, aliphatic amines in this decreasing order of basic nature in gas phase. Okay, tertiary amine most basic, then secondary, then primary, and least basic is ammonia. Okay, this order of basicity of amine is in gaseous phase, remember it. Okay, now basic nature of aliphatic amines in aqueous solution. In aqueous solution, solvation effect and steric hindrance also affect the basic nature along with the plus I effect of the alkyl group. Okay, first we'll discuss what is the solvation effect. In the aqueous phase, the substituted ammonium cation. Substituted ammonium cations means after getting proton from the acid, that amine will convert into this substituted ammonium cation. And this substituted ammonium cation gets stabilized also by solvation with water molecules by forming hydrogen bonding. Now see, this is the decreasing order of extent of hydrogen bonding in water and order of stability of ions by solvation. We can say the substituted ammonium cation formed from the primary amine is most stable because it has these three hydrogen atoms and these three hydrogen atoms can make the hydrogen bond with these three water molecules. In case of secondary amine, that is ammonium cation found by the secondary amine, only two hydrogen atoms are there. That's why only two hydrogen bonds are formed. That's why this is less stable compared to this one. And this is the ammonium cation formed from the tertiary amine. This is the least stable. Now, if we consider only this solvation effect in the aqueous solution, then the order of basicity of aliphatic amine should be reversed. Okay, now on the basis of this, only this effect, primary amine should be most basic, then secondary and tertiary amine should be least basic. Okay, steric hindrance. When the alkyl group is small, like CH3 group, there is no steric hindrance to hydrogen bonding. In case the alkyl group is bigger than CH3 group, there will be steric hindrance to hydrogen bonding. Therefore, the change of nature of the alkyl group, for example from CH3 to C2H5, results in change of order of basic strength. Clear? Now we are having three effects in aqueous solution: inductive effect, solvation effect, and steric hindrance of the alkyl group. And all these three effects, again remember, inductive effect, solvation effect, and steric hindrance of the alkyl group decides the basic strength of alkyl amines in the aqueous state. Okay, now if we are having ethyl substituted amines, then secondary amine is most basic, then tertiary, then primary, and least one is ammonia. Now if we are having methyl substituted amines, then secondary amine is the most basic, then primary, and then tertiary, and ammonia is the least basic. Now for the sake of remember, okay, how can we remember this order? This is ethyl substituted. Ethyl group is larger, okay, and if we arrange this secondary, tertiary, and primary, we will get this number 2, 3, 1. Okay, this is secondary, tertiary, and primary. And in case of methyl, methyl is smaller. Methyl group is smaller than ethyl group. And if we arrange this secondary, that is 2, 1 primary, and 3 is tertiary. This is a smaller number, 2, 1, 3. Okay, for methyl substituted amine, and this is 2, 3, 1. This is the larger number for ethyl substituted amines. This is the shortcut method to remember this order. Is it clear? Now, Arylamines versus ammonia. We already discussed it. Arylamines are less basic than ammonia. Now, what is the reason? Because lone pair of electron present on nitrogen atom is delocalized in benzene ring due to resonance, and thus it is less available for protonation. You can see these are the resonatic structure. This is a lone pair of electron present on this nitrogen, and this is delocalized in the benzene ring. Okay, and this nitrogen acquires the positive charge. That's why this lone pair of electron is less available for protonation. One more reason. On the other hand, anilinium ion obtained by accepting a proton can have only 2 resonating structures like this. These are the 2 resonating structure for anilinium ion, while they are the 5 resonating structure for aniline. Greater the number of resonating structures, greater is the stability. That's why we can say aniline is more stable compared to the anilinium ion. Hence, aniline is less basic than ammonia. Okay. Now, in case of substituted aniline, it is observed that electron releasing groups like OCH3, CH3 increase basic strength. Okay, whereas electron withdrawing groups like NO2, SO3H, COOH, halogens decrease basic strength. Clear? Now see one example. Arrange the following in decreasing order of their basic strength. This is C6H5NH2. Now this is aromatic amine. Okay, this is C2H5NH2. This is aliphatic primary amine. This is C2H5 twice NH. This is aliphatic secondary amine, and this is ammonia. Okay, we can say this is aromatic amine. It means this is the least basic, and this is lesser basic than ammonia. Now these two, these are the aliphatic amines. These are the more basic than ammonia. Okay, but out of these two, which is more basic again? We can say this is secondary aliphatic amine, more basic than primary one. That's why this is the decreasing order of basic strength of these amines. Okay, thank you. Subscribe my channel to get the next video from this chapter.